All right, hello again. These are the two skills that I didn't get to teach you guys. And these two things are like, it makes trig completely obsolete. And usually, all that stuff we learned with right triangles, is now superfluous. Now that we know all of that stuff, we're able to figure out these two laws. And this is the law of sines and the law of cosines. And these two laws are the most useful thing. This is the entire reason we learned trig, was just to get to these two things, because they make all the calculations of trig possible for any triangle, not just right triangles, but oblique triangles. Oblique triangles are non-right triangles. And so this works for all types of triangles, obtuse, acute. They don't have to be right triangles anymore. And normally I would go through and we would derive these formulas. It turns out it's pretty easy, but because, we're not together, I'm just going to give you the laws. And so it turns out that if I have a triangle, and this is an oblique triangle, which means it does not have a right angle. So this is your standard sort of naming for a triangle. We use capital letters for the vertices. So it's capital A, capital B, and capital C. And then the sides opposite those angle measures get lowercase letters. And so this is opposite angle A is side A, opposite angle B is side B, and opposite angle C is side C. And what happens is we are going to use law of sines. It turns out that we can create these little proportions, that the side A over the sine of its angle A is the same as side B over the sine of angle B, or vice versa. We can use it with angle C. So basically, the side is proportional to the sine of its opposite angle. And that is the law of sines. And we can take whatever information we've got. So maybe we have information for angle A and side A and C and side C. And we can create these proportions that are really easy to solve. So law of sines is really, really cool. And we use law of sines when we have lots of information about angles. So if I have angle side angle, so for instance, angle A, a side B, and angle C. So angle side angle, then we can solve using law of sines. Or even if we have angle angle side, then we can also use law of sines. Here's law of cosines. Law of cosines looks a little more complicated, but the ideas are the same. And I'll highlight this when we go to do it. But it turns out that, so say I have a square with side A here. So we want to maybe find this length, side A. Well, it turns out law of cosines is that side squared is equal to, and I do this a lot. So I'm just going to circle those opposite side and angle. So if you imagine that side length squared is equal to the side squared plus side squared, the other things. So B squared plus C squared minus twice BC, so multiplying them all together, times the cosine of that included angle. So the included angle is the angle between those other two sides. And that works for all of these things. So if I'm over here and maybe I've got this information, or I want to find side B, B squared is equal to A squared plus C squared minus twice the product times the cosine of angle B. And so it's just a pattern. And once you learn the pattern, it becomes pretty easy. So feel free to pause the video and write down these rules, but none of the letters are going to match. So really just memorizing the pattern is kind of the way to go. All right, so example 1. Use law of sines to find the measure. So I'm going to use lots of colors to kind of help us out here for law of sines and cosines. And this is exactly how I would teach it normally. So round to the nearest 10th, you are going to have to use your calculator. And you can see that they've given us degrees. So we want to make sure our calculator's in degree mode as well. So first of all, I want to start with information that they gave us. So I want to make sure, I want to look for opposite side and angle pairs. And so right here, I see that I have an opposite angle of 51 and its opposite side of 11. And if I have those pairs, a side and an angle pair, then I'm going to start with that information. So 11 over the sine of angle 51 is going to be equal to whatever else I've got here. So looking at other information that I have this angle 62 degrees and its opposite side is t. So I could set that up as t over the sine of 62 degrees. And once you've set that up, it's just a matter of cross multiplying. So I'm going to isolate t. So all I have to do is multiply by the sine of 62 on both sides to get t by itself. And so in my calculator, I'm going to type 11 times the sine of 62 degrees divided by the sine of 51 degrees. And if you type that into your calculator just like that, it'll be perfect. I guess I will say it's a good idea to put parentheses around the numerator and parentheses around the bottom denominator. So I'm going to do that just for safety's sake. And again, absolutely no rounding until you're done. Sine of 51. So you can see I put lots of parentheses, so I'm sure to get it correct. So I get 12.497. So t is approximately 12.497. And they're telling me to round to the nearest tenth. So the nearest tenth, again, we go to the hundredth spot. It's 5 or more. So that's going to round up our 4 to a 5. So 12.5. All right, again, looking at two pieces of information that I know that I have here. Oh, look, so I have 23 in F. I have 17 in H. So it's not a ton of information, but I'm going to go ahead and I can actually figure out, because I have two angle measures here, I can figure out angle G, right? So angle G is 180 minus 117 minus 23 degrees, and that'll give me angle G. So let's do that first. 180 minus 117 minus 23. So angle G is 40 degrees. So it might be necessary to figure out another angle first so that we have a side with an angle. I'm looking for that pairs to start off. I need two solid pieces of information. So our side of 10 is proportional to the sine of our 40-degree angle, which is going to be proportional to, we're trying to find H. So I want to use my side H here, and that's opposite the 117-degree angle. So H over, sine of 117 degrees. Again, I want to get H by itself, so we can think cross multiply or just multiply by the sine of 117. I want H by itself, so I'm really just going to do that. That's going to be 10 times the sine of 117 degrees over the sine of 40 degrees, and that's H all by itself. So again, I'm going to plug that into my calculator very, very carefully, and I am in degree mode. 10 times the sine of 117 divided by the sine of 40 degrees. And I get 13.9. I'm going to round that 13.86 up to 13.9. So law of sines. One more. All right, again, we're looking for an angle and an opposite side pair, and I have that to start, which is super nice, and I don't have enough information, so I must have forgotten to write something down. Oh, I surely did. This angle is 110 degrees. Whoops. Sorry about that. Okay. And we're trying to find side Q here, and I have its opposite angle, so that's nice. So I'm going to start with my side of 5 over the sine of 18 degrees is proportional to Q over the sine of 110 degrees. All right, so again, all I need to do is multiply that sine of 110 to the other side. And that's the easy way to isolate Q. So 5 times the sine of 110 over the sine of 18 degrees. And that's what I'm going to type into my calculadora. 5 times the sine of 110 divided by the sine of 18. 5.2. I'm sorry, 15.2 is Q. All right, so hopefully that's good enough for a lot of science. Really useful stuff there. Works for all kinds of triangles. All right, now law of cosines. Use law of cosines to find the measure. Round to the nearest tenth again. All right, we are trying to find Q here. And so because I am trying to find Q, I'm going to go ahead and circle that and its opposite angle because that's really useful. And this is law of cosines. So you can see the information I'm given for law of cosines. This is a side. We have an included angle and a side length. So when you have lots of sides, we can use law of sines. This is side angle side. And so the sort of pattern here is I'm trying to find Q. So that side squared is equal to the other sides squared, the sum of the other side squared. So 5 squared plus 11 squared minus twice the product. So the product of those sides, so 2 times 5 times 11, times the cosine of their included angle. And that included angle is that included in between the two sides is that 34-degree angle. And that's the setup for it. That's how it works every single time. So I like to circle those things, and I find that really helpful. And from there, it's just solving, working it out, really. So we have 5 squared is 25. 11 squared is 121. 10 times 11 is 110 times the cosine of 34 degrees. So I'm going to go ahead and put all of this in my calculator. 25 plus 121 minus 110 times the cosine of 34. Again, I'm in degrees because this is 34 degrees that they gave us. And so we have Q squared equals 54.80586, yada. Do not round. Do not round until you're done. To get Q by itself, I need to take a square root of both sides. So I'm going to keep that answer in there and just do the square root of the answer. And you all have an answer button. It's a second function, so second answer. And that's going to take the square root of our answer that we have. So 7.403. Rounding to the nearest tenth, we look to the hundredths. It's less than 5, so we keep our 4. So Q is 7.4 units long, whatever that unit happens to be. Again, round at the end. So solving for that side length is pretty easy to do. And here's when we're actually solving for the angle measure. But you might have to do on law of sines as well. I'm not sure if that'll come up or not. We actually want to figure out what this angle measure is. And the nice thing is I have this opposite side of 15. So I'm going to set this up just like I did the last one, and it just has to do with rearranging. So that setup, just like the last one, is side squared is equal to the sum of the squares of the other sides. So 6 squared plus 17 squared minus twice the product times the cosine of the included angle. And that included angle is angle X. And that's what I'm trying to find. So what we need to do is actually work on isolating the cosine of the angle. So I'm going to sort of simplify, clean this up a little bit, and then move everything away from that cosine of X. So 15 squared is 225. is equal to 6 squared is 36. I don't know what 17 squared is. Oh, I did know that. Okay. And 2 times 6 times 17. So minus 204 times the cosine of x. All right. So I can go ahead and add these things. 36 plus 289 is 325. Now, the common mistake here is students like to do 325 minus 204. Can you do that? No, you cannot. This has an x, a variable attached. They're not like terms. So I'm going to go ahead and subtract the 325. 225 minus 325 is negative 100. Equals negative 204 times the cosine of x. And to get cosine of x by itself, I have to divide by negative 204. So divide by negative 204, and I get 0.4901, yada, yada, yada. Do not round. Now, to get x by itself, and you might have to do this with sine as well, to undo the cosine function or undo the sine function, we need the inverse. So we're going to do the cosine inverse of both sides. If it was sine, you would do the sine inverse of both sides. Cosine inverse and cosine cancel one another out, and we get the angle isolated by itself. And then on my calculator, I need to do my inverse function. So do cosine inverse of my answer. So again, I'm using that A and S button. So second answer. And then I don't have to type craziness. You just get to use your calculator and have it do it for you. So we get 60.646. Again, they want you to round to the nearest tenth, which means go to 100, the 100th spot. And if it's 5 or more, you round up. But this is not, so we keep it 60.6 degrees. And you can see there was a little degree symbol on the IXL. So again, make sure your calculator is in degree mode for sure. All right, so really, sometimes you can solve for the angle, and that might mean you need to use an inverse function. And the same would work for sine, law of sines as well. If you're trying to find the angle measure, maybe you need to do sine inverse to get the angle by itself. So think about that, and hopefully you sort of figured out this pattern with your opposite side and angle, and then all the other numbers in there. All right, folks, that's law of sines and law of cosines. Good luck. Have a great day.